Hi, exploring another volume example. Here we're looking at a cube. We're looking at a cube expanding. Okay, so this is kind of odd to think about, but basically imagine a cube and then it's just growing and growing and growing. Okay, and so edges of a cube are expanding at a rate of 4 centimeters a second, and so we're supposed to determine the rate of change of the volume when the side lengths are 25 centimeters. So once again, just going through the same process. Hopefully, if you've been watching the other videos or finding other, really good ones online out there, okay, you'll find that we generally start by drawing a picture if it's applicable, which it often is, okay. So we got ourselves a cube. Nice little visualization. And we know the sides are expanding at a rate of 4 centimeters per second. So let's label the sides. Okay. Typically what happens here, if a kid starts going down the wrong road, they'll call this like X, Y, and Z, or length, width, and height. And those are true, but we don't want to have 3 variables here, okay? Because it's a cube, we know that all 3 sides are the same, so we don't want to give them different variable names when they're all equal. So let's just go with X. So they're all 3 X, okay? That's so much easier to work with. So let's list what we know. We know the change in X, okay, the change in that side length is going to be 4 centimeters a second. And we're going to try to find the change in volume with respect to time when that side length hits 25 centimeters, okay? So as this thing expands, there's going to be an instant, just a split second, where that thing's 25 centimeters, this is 25 centimeters, that. And it's going to keep going. At that moment, how is the volume changing? So we need a relationship between volume and, so between the 2 variables really here, we need a relationship between V and X. So you hopefully all remember the original volume question you were ever taught, length times width times height. So your volume equals X cubed. So now we're going to take the derivative and say, okay, the change in volume, the rate of the change of the volume equals 3x squared dx over dt. And at this time, we're hoping that we can plug in what we have and that we have enough information. And we're going to in this situation. So we're trying to find dv over dt, so not a surprise we don't have him. 3 times, okay, we do know in this instance that x is going to be 25. And then we know that dx over dt is 4, okay? And so basically it's going to be cleanup at that point. Let's go on up here. Of course I don't have a calculator on me, so I'm going to try to use it in my head. So 25 squared is 625 times 12, whatever that number is. Let me try to find a calculator real quick. So I got 7,500 cubic centimeters a second. Hopefully this helps.